Welcome to this video on why PHIMS is becoming critical for U.S. AI data centers, microgrids, and investor positioning. The challenge is the structural shift in electricity demand driven by AI and data centers. The solution is PHIMS's Power Intelligence, which manages power at the facility edge. This represents a billion-dollar investor opportunity by monetizing rapid data center expansion and grid flexibility programs. This executive summary reiterates the challenge of surging AI-driven demand. DOE/LBNL projects U.S. data center electricity use to reach 325 to 580 terawatt-hours by 2028. PHIMS, as a solution, buffers high-frequency load transients and enables controllable microgrids. The investment opportunity lies in monetizing rapid infrastructure expansion and grid flexibility. The AI electricity crisis in the U.S. is reflected in recent data and projections. Data center electricity use is rapidly growing, potentially reaching 580 terawatt-hours by 2028, representing 12% of total U.S. electricity. This translates to an approximate average load of 66.2 gigawatts by 2028. Key drivers behind AI-shaped load growth include increased GPU power density, which requires more cooling. Cooling itself is becoming a first-order electricity driver. The need for liquid cooling and managing large campuses with utility constraints further emphasizes the demand for power management solutions. Data center power and grid constraints are the new bottleneck. We are seeing a power plant plus data center campuses trend. Transmission and interconnection are the gating factors, with connection wait times exceeding a decade. Reliability is challenged, and slow grid build-out contrasts with fast technology cycles. Mapping PHIMS to microgrid controller functions highlights its value. PHIMS acts as an integration controller layer with a surge buffer, coordinating solar panels, storage batteries, and power conversion. This addresses reliability planners' concerns and strengthens power quality for data center systems. Supercapacitors are important for AI data center loads because AI workloads create rapid transients that standard batteries struggle with. Supercapacitors offer high power density, millisecond response, and long cycle life, ideal for burst loads. They optimize generator sizing and provide critical ride-through capability for brief interruptions. The reference architecture diagram shows PHIMS connecting the grid and local resources like supercapacitors, battery storage, and generators to the facility load. PHIMS controller, along with power electronics, manages the flow, utilizing input from an energy management system, EMS. Analogous deployments and proof patterns confirm the relevance of PHIMS components. Supercapacitors are already used in UPS for short-duration ride-through. AI data centers show real-world load variability, and microgrid controller functions are testable today, demonstrating capabilities needed for islanded energy management and voltage constraint management. Investor positioning requires thinking about market size rigorously. PHIMS is positioned as a platform capturing a slice of data center electrical infrastructure expansion and microgrid deployments. Massive physical build-out is implied by official load growth, and large data center costs support the market sizing.